Hi everyone, Alex from AutoStore here. So this is the first video of my next series that I'm going to go through, and that is going to be how to design an AutoStore. So I'm going to go through everything from first concept phase of what we actually need, like lines per hour or bin presentations per hour, all the way through to actual selection of which ports you're going to use, which robots, and why you might select any of those. So first episode today, I'm going to do using our Smart Designer. So this is as basic as it kind of gets. And just to give you an idea of what the basic numbers we would need to be able to very quickly put together a grid, a design, and give you a price. So all of that can be done in about sort of 10 or 15 minutes if you've got all the data available. But hopefully over the next couple of weeks, you'll see how quickly that happens and then move on through the more detailed design. But I hope you enjoy it. Okay, so this is our Smart Designer, and this is what we can use as a sort of first pass, building a concept and building out what we actually need to design. So firstly, it's our throughputs, and this is usually using the sort of peak numbers. So it's in bins per hour, and as a first pass, we see bin presentations to the operator as the same as lines per hour. So we'd assume that it's a single SKU bin. So let's just say, use this one round numbers, say 1,000 bin presentations an hour or lines per hour. And then as a first pass, we'd usually say your goods in is around 10% of that. So let's go for 100. So we know across number of shifts, we can say that it's a 2-shift operation, and the bin distribution, or your kind of ABC curve or Pareto, we're just going to start with 80-20. We can then adjust that depending on data further down the line, but we'll start with 80-20. Can then select our bin type. So we've got 3 different bin sizes of the 220, 330, and 425, all of which have a 600 by 400 mil internal diameter. So I'm just going to go for the mid-range 330. It's the most commonly used one. Can then select total bins. So if we're going from like a manual warehouse, maybe we'll take this as total locations you've got today. So let's go with 45,000. So we've got 45,000 bins as our aim. And then the height of the building, we'll say 12 meters. So next step for what we need is how long the operation kind of takes when we present a bin. So this is how long it takes for the picker to pick something out of the bin and how long that bin needs to be actually in front of the picker. So if you're doing a pick and pack operation, you might want it to be there for 10 or 15 seconds. Pick and pass, we've got systems running 5 seconds and anything in between. So I'm just going to put in 15 seconds as a sort of starting point if we're doing a pick and pack operation. And then goods in, it could take a lot longer if you're filling a bin with multiple SKUs. So let's go for 45 seconds. So what the Smart Designer then does is pulls up what it recommends. So it comes up with a few different scenarios, but the green is what we'd recommend as a starting point. So that would be 40 R5 Pro robots, and then that would give you enough capacity for 1,111 bins per hour. 5 carousel ports, but the utilization's pretty high, so maybe we'd go for 6 carousel ports, and then you're inbounding 2 conveyor ports. So that gives you a basis of what we'd need to design. So hopefully that gives you a good idea of what we'd need to build out a first pass concept, and you can see how quickly we can build that. Next week, you'll see how I put that into a grid design and give you an idea of what the footprint requirement would be and to build out a sort of 3D concept nice and quickly. Hopefully catch you then. Cheers.